Hello, everyone. How are you? If you've been waiting for me, here's the time I'm coming back. And because I'm have kind of like starting this late, so I won't be able to actually do a long stream. But because I was planning on doing it, so I thought, well, I still like to do it, even though it's just going to be a very short one, not going to be of too much use. But I just thought, it might be good too. At this right now, we're in the middle of the summertime now, so and let me make sure that my sound is good too, right? Because sometimes I think my sound, it can be weird too, but let me test it on my other system. Oh, okay. I can hear it. So, okay, sorry about that. So the reason why I thought would be kind of good to get back, because for one thing, right, I was on pretty much on a 5 month or so hiatus. As I was thinking, because my mother was not well, and then ended up she passed away. That was back in March, and so when I was like looking back, it's been like 5 months, and I was on the road a lot, and then didn't get to do my streams. And I think a lot of folks probably have forgotten about my stream, which I think in some way was okay too, because as I was thinking, right, so much has changed. And for one thing, right, I got a new mission. Now I'm like in a new team, but essentially two company is evolving. So I'm actually no longer doing just streaming, although streaming is still kind of part of my repertoire, I should say, but it's a bit of a in the background. So, and now too, all of a sudden I have to like pick up a lot of new things, which I'm pretty very I'm welcoming to, let's put it like that, right? But it's not easy, because now I'm actually have to look into generative AI, so machine learning, AI stuff, although a bit more with an emphasis on what my company does, which is, the data, primarily still a database Cassandra company. So we have implemented vector search, so it's essentially qualify as a vector database, and as such too, it just means that there are data that's being easily or kind of more efficiently designed to allow for, very efficient like big data search. And it's kind of, for this kind of search is really for, if you kind of think of it, right, AI, machine learning, with the steps are, in case you're not familiar with it, we need to like train the models. So essentially too, let me just kind of talk through it a little bit, because AI, machine learning are essentially, right, we want the machine to be able to think on its own. So in order to do that, then we need to train, like train the machine to do it. So these are like based on the model, right? And that's what we call some model, right? That's kind of built based on data. So then the machine can learn it, right? The bot, so to speak, right, can learn it. So that's machine learning. It can be like supervised learning or unsupervised learning or reinforcement learning too. So that for those two, I can kind of go into a bit detail maybe next time, but just kind of bring those up. So I think those are a bit more of a traditional look into AI, but as such, right, things are changing so fast now. So as we all know, ChatGPT is like the latest trend now. Everybody's kind of talk of the town for a few months so far. I think it came out, I think the version that's GPT-3, I guess that's really the fanciest, right? That first came out was back in, I think, November or the fall of 2022. So now everybody's talking about it. And essentially, too, what it is actually doing is essentially doing text. And then there's a lot of text search, right? It's called vector search. But the thing is, too, what it's actually trying to do is kind of pattern matching too. If you kind of think of it, right, we live in a world, a lot of things are just, we model, and we have a lot of patterns. So these are like pattern matching, but they are fancier. And it's kind of enabled by implementing like vector search, on our system. So in this case, my company too, we're a data company. So it's very much like the database is called vector database now, but that means it supports vector search. And it just means that, you're doing searches, kind of like doing a lot of pattern matches. The fancy thing is that it can do all of these pattern matching or searches in parallel. So it makes it really fast. So it can operate on huge amounts of data. So that's why it's in kind of, important too. So So now then, back to the AI, then machine learning, right? All of the steps to first, the data is the key, right? You need to acquire the data first, and then they have what they call like data cleansing or massaging or whatever you want to call. I forgot exactly. Sorry, but the thing is, it cleans all the data. So after that, then it will needs to go through what is called like training, right? You train the model now. So it's you look through all the data, and you have different rules of identifying, categorizing, classifying all of the data. Now, the thing is, too, is that they're essentially kind of two broad, really broad categories of data. One is actually text, right? You're searching through text and identifying, that's the thing right now when we're talking about asking ChatGPT to write your resume for you, for example, right? You give it some input and it figures it all out. And basically, too, it's just based on the data it enters. And then that's the thing, it does the training first, right? So training actually can take a long time too, as you know. And also, too, not only that, right? It's kind of, I bring into a bit of a hardware essentially to doing training in huge amounts of, large quantities. I mean, I'm not talking about just gigabytes, but these are like, I guess terabytes, petabytes of data. So these are actually the machine on the machine level will be using GPU, right? Graphical processing units. These are basically, they're very efficient and operating, they are different from CPU because CPU, computer processing unit manages everything in a computer, but GPU essentially it's very efficient in rendering. It's supposed to be rendering graphics, but the thing is, it's kind of now being also used for machine learning kind of processing, right? Is doing a lot of linear algebra. If you're kind of a math person like me, you know that it's essentially kind of, it's what it does, it looks at the data, it classifies it, and also assign it certain tokens too. And with those tokens, they're being kind of stored into the database. And because, and that's the thing, for example, my company, DataStax, we store all of these, you have to first look at the data and then classify it and then convert them into certain tokens so they can be stored kind of very efficiently and also being searched and matched efficiently too. So that's the thing. And so now we are relying on, when you're training too, you're using GPU machines, right? It can easily, maybe a GPT-3 kind of model could take GPT-4, right? They can take easily, maybe take, like a cluster of machines with 30, 40 GPUs, and they process some data, maybe take days, to kind of do some kind of huge amounts of data, because if you kind of think of it having had to ingest all of the data in this world, or, in a large quantity, you need that level of kind of machines. And so that kind of brings into another question. Let me kind of share with you now. So see behind me, like now, if you've been following me, you notice that I sent out a poll, right? About a week and a half ago, and then the poll actually closes, and I have yet to digest it a little bit and also analyze and then publish that finding, but which is something I'll do. But I do have to say, somehow I'm just very, very busy. This summer, I actually have to also take care of a family member who's kind of coming into town, right, into Chicago to visit too. And I actually have to go. I'm already running behind, but I told her, okay, just wait for me. So anyway, so just too much stuff to do. But like I said, let me kind of do this one thing and share with you this. And let me not block it first. Wait, why is it not? Okay, there we go. I just want to make myself shrink so you can see this, right? So first of all, this is my poll. If you've been following me, you notice that I asked a poll in here, right? Because I'm kind of interested to know, from a developer advocate point of view, also like for my company too, we like to know, right? Part of it, I'm Java champion, so I want to advocate for more Java folks to adopt, kind of machine learning. And I know too, it's funny, right? But I'm like talking to a lot of folks, from Java field. Some they just don't even care, basically. I mean, not to say not care, but they're like, oh well, what's the big deal? I'm already busy enough, which is true. But the thing is, just wanted to tell you too, there are benefits too as to this technology. I believe that it will kind of become the centerpiece, right? A lot of positions and future roles, near future roles will depend on it. So like it or not, we all need to be learning it. But to me, I look at it that way. It's kind of good to learn new things. Is how I look at it. But in any event, so this is the so I want to see like a general sentiment of our Java developers. And so I asked about, well, Gen AI is primarily focusing on Python. And so what about Java developers? What do you feel? So first, we're saying Java will catch up. It's actually not too bad. Almost half of you from, how many votes? 134 votes. So thank you very much for voting if you did and share your opinion. Some of you too, are kind of commenting a lot of things. So one of which I actually wanted to say is that the comment actually was saying that, if you think about, yes, it is Python, but underneath the hood is actually C and C++ libraries. Well, now this goes back to the fact that why, and that's because, C and C++, I have to say that they are designed to work very well with with GPUs, actually. I guess even from what I learned is that Java may not even be the most efficient language to work with GPUs, but whereas C++, they are kind of more like, kind of like down to the core, kind of, closer to the machine kind of system or language, framework. So they actually are designed better to work with GPUs. And how, I need to kind of figure out exactly, but that's the understanding. So now the thing is too is that, computers, right, are, I should say, a lot of the, kind of scientists, right, that are into designing the mathematicians, they are not necessarily computer people, where, we're kind of more, I'd say more Java developers, we pay more attention to, um, you know, uh, best practices, for example, designing your systems, all of these, whereas, from what I know too, I know I started off doing C and C++ and some C++, but in general too, it's just not as, kind of talked about, I should say. So it's just naturally being picked up by scientists, right? And they're maybe mathematicians, in this case, data scientists, and language like Python is actually much more easier too, I do have to say, because, Java, for example, it just requires a bit of a ceremony, for lack of a better word, right? You need to set up your stage, so to speak. But whereas Python, you can just start coding, and pretty much is just more straightforward. However, the drawback is that with Python is that it can't handle threads too well, right? And it's not designed for scalability. It's just for more prototyping type of thing. So now the thing is, with data scientists, a lot of times too, they also are not so much about, the software engineering side. So they kind of pick up. So they started off doing Python. Now the thing is, going back to, this comment by my friend, in the community, colleague, I think it was Tom Cools, and that most of them are just like wrapped. These are not really Python underneath the hood. These are C and C++. Yeah, because a lot of these algorithms, right, they're kind of dealing with the math, the matching, the linear algebra. As you know, linear algebra is really about vector, and I believe that's how the database industry these days are borrowing, using the word vector, because it's essentially too for vector. And what is vector, right? You might ask. Is basically, right, in math terms, is essentially they are opposing to scalar, I should say, scalar type of processing. Scalar is more simpler, right? So you have a processor, it's just like processing one piece of data at a time, whereas for vector processing is you can have many pieces of data elements that, one instruction can process them at once, kind of like that. So it kind of gives more power. It's more powerful too. So that's vector. So that's kind of get back into some kind of basics. And also linear algebra is essentially, right, the study of this math is about vector, about matrix, right? In like, say, an array, you want to like do multiple things like multi-dimensional kind of arrays and trying to process them like that. It's actually, I have to show you another, maybe my next time, let me show you that particular example by this gentleman who posted on LinkedIn, that I thought that was very good about how it works, right, with vector class, if you use vector type of processing versus like scalar kind of processing. So I'll show that to you, from the coding level. So that's why too, vector processing is just important. So now that's the technique that these database vendors are using now with vector search, and they have to again convert data into certain tokens. So then you store these as vectors, and then it helps in the searches being much faster and being able to do it in parallel. But anyway, the long story short. So let's go back to this poll, right? So we're saying Java will catch up. So that's a good, well, that's a good view too, and I do believe it is. And Java probably still, like Python too, is like wrapping around some of these C++ libraries through maybe using JNI, right, Java native interface, to do it too. But the thing is too is that there's still a lot of things that Java can do, because, well, that we should consider using Java. As we know, is a language that's built more for the enterprise, right? And scalability kind of aspect, we know, kind of unbeatable too if you kind of compare Java with other languages such as like Python or other, right? So Java is still dominating the market, in the enterprise world, in production systems too. So okay, so that's good. Java will catch up. There's like about a quarter of us, right? 23%, almost 25. Let's say a quarter of people still think, well, I'm not sure what to think. Maybe those are the people as more kind of saying that, well, I don't really quite worry so much, or I don't care. And then there are also about 16.4% or like 16, 17% people said, I'll you switch to Python, just adapt, and then there are also like 12.7 people said, well, I'll start researching. I'm not going to give an answer, kind of a definitive thing yet. So let me kind of do some research. So thank you very much. And it's got 2,585 views. So thank you very much. So now let's take a look at the result that I first posted in, I believe. So let's take a look at this. All right. So this is this. And it's got like 2,663 impressions. So this is roughly the same as it was on Twitter. So thank you very much. Like I said, I'm gonna like publish just a thoughts, based on these responses, right? If we kind of take a look at the analytics too, I bet it will be interesting, right? This many reactions. Well, 9 people reacted, 3 comments, and 4 reposts. But the thing is interesting too, like top demographics, right? That they're usually these are like big employees or companies that have 10,000, so the large corporations, so got the most responses. And I do believe, Java is still primarily kind of being used by enterprise big organizations. And then there are also like, kind of smaller companies like 51 to 200 employees got 225. And so those are probably a bit of a larger, maybe like, kind of a startup, not quite startup, but just small companies. And then there are also some that are 1,001 to 5,000 employees, about 192. And then 11 to 50, these are probably more like the, kind of startup companies. It's got a good number of folks responding and or responding, more like viewing. So it means 2. And then about 500 to 1,000 employees, company, those are about 133. So thank you very much. So these are just some of the statistics, and let's take a look. So okay, so I think it's like on Twitter too. 50% says no worries, Java will catch up. Not sure what to think of that. Over there is like 23%. Here we get 20%. Time to switch to Python, about 20%, a bit more people. And then some will say I'll start doing some research. So it seems like 84 votes out of that. So it's pretty much a kind of same kind of sentiment, right, among Java developers, I guess, that responded. Okay, and I think there's one more, right? If you kind of know that I'm also on Mastodon too. Mastodon is I've got like a smaller group of people, but let me also take a look too. Let me kind of do this, and let me bring it over here. So this is my Mastodon, and if you like to follow me on Mastodon, you're welcome to as well. I'm like mgrigless, right, at fuj.social. That's me. So over here, 40%, right? There are fewer people, as you can see, right? How many number of views? It actually doesn't that much. Refresh. I guess that's it. Only 15 people, I guess, voted. I guess there are 40% that says no worries, Java will catch up. Not to think sure what to think of is about 7%, and then 40% said time to switch to Python. More people think we should switch to Python, and about 13%, roughly the same as on Twitter. That ratio, I'll start doing some research. So Thank you very much again. But here I can't tell how many people. Let me see. Embed. Oh yeah. So it doesn't. Uh, wait. Why is it not showing me like the number of views? Right. Okay. Well. Anyway. Somehow over here it's not giving, but in an event, so now we know, so it's just kind of like roughly kind of like the same sentiment whatever platform you're in, so kind of proves it is a general sentiment. So definitely too there will be Java developers, I think, to be adopting it, which is the good news. So, and like I said too, let's kind of take a little bit more into Gen AI. I think I've been like streaming for about almost half hour. So in about 5 minutes, I probably will kind of turn off, or kind of finish my stream here. But because I need to pick up my friend and family, who's waiting for me in downtown Chicago. So okay, so again, Gen AI, right? So here are the few terms that we need to be thinking of. These are generative AI, and the kind of like juxtaposing would be predictive AI, right? So generative is basically also about the results are being generated based on the data that it encounters, right? And predictive is maybe some of you can kind of comment on it if you're already experts too. I kind of somewhat like feel a bit so to speak, like get a bit confused. I feel like Gen AI can also be maybe a subset, right, of predictive too, isn't it? Because predictive, you're making predictions based on some input, right, and then you look at the model and then make some predictions. So, and usages can be like in like recommendation, right? You go shopping, there are recommendations. Those are predictive kind of AI. Or generative is basically like Chat GPT based on some text. You maybe like wanting to say, well, look at my resume. I want you to, put together a cover letter for me. Those are generative. So there are differences. But Gen AI is kind of becoming the thing, is in it, and that's because essentially to think of this artificial intelligence. That means you don't want to do so much work. You ask the machine to do it for you, right? Looking at some pattern, go figure it out what it should be. So that's only the at the tip of the iceberg, so to speak. There's still like plenty of opportunities that we humans we can still think of to come up with too. So maybe those are not limited to just that, right? There are many other things. But the thing is, though, we have to make sure is that we're not violating, or kind of like endangering anybody or hurting anybody or violating like security, kind of privacy type of thing. So that's also very important. And also too, another topic in AI too that I'm aware of is basically the bias API, right? So, or I'm sorry, bias AI bias, right? So which means that we're training the model maybe in certain ways where the data we come into is already biased. Maybe like there are certain buying patterns, right? That kind of like assume people will buy some things, and they're assuming only maybe like a certain how can I say, like a population will be interested in certain products, right? So that type of stuff, and those are kind of product recommendation is probably okay in a sense, right? It just means so your recommendation isn't going to serve all population types. But the thing is, what is not good is what if you have to look at these data and make a decision of college admission, for example. I'm not saying that exactly, but it could be used for college admission based on some data input by all the candidates submitting, right? They might be like looking at certain types of kind of favorite, right, as criteria to accept someone. But at the same time too, because those criteria could also be representative of certain racial groups or something, like ethnic groups, for example. So those are kind of things we need to be thinking about, not just like doing the fun, kind of like thing, so to speak, but a lot of implications, a lot of like, social impact to it too. So that we need to be aware of. So, okay, so again, these today we just look at the results of the poll, and like I said, I'll do some more kind of analysis, kind of come up with something. And please look for me, on my poll too, and we'll not poll. I'm sorry, what am I talking about? and look into, like, just wait for me to publish a blog post. We'll kind of have some more discussion over it. I feel that it's kind of like a very interesting, um, kind of like an area that we can think of. So, all right. So, but let's see, right? Okay, over here, let me kind of look at some things, and let me see. I'm sorry, and over here. Um, what I wanted to look at is that, well, at my company, DataStax, right? If you want to play around with our vector search, right? So over here, go to astra.datastax.com. Oops, hold on a sec. Wrong thing. Okay, here we go. I need to go back to here, and then I can give you the link to our Astra. This guy. Okay, here we go. Astra. Where's Astra? Here we go. Okay, so this is the link, right? Astra.datastacks.com. So yeah, go to this link here, and again, sign up, right? If you kind of go over here, sign up. It basically allows you to sign up to our free use of our $25 free credit per month. Use this, right? And sign up, right? Using your Google single sign-on Google, or using GitHub too, that's supported. Or you can sign up using your email address, and there's no need for credit card, which is great. And then if you use up your $25 that month, you get another $25 in the next month, and so on and so forth. You get up to $300 per year. And if you need more, if you are doing important research, or doing your own startup, you can come to us, and we can actually help you too if you need additional credits, or if you're doing something that you're leveraging on our technology. So, okay, so let's kind of take a look, right? So let me then sign in with my account in here. Okay. Okay, here we go. So as such, right, vector search at our company Astra managed cloud platform is now production ready. It got released like a week or so ago, so very new. So you want to read the blog, right? Click on that and read the blog, and you can also, in this case too, you basically can get some high level idea what it is. And let's go back here, and basically you can then start to create database. You can do vector database and give it, say some database name and the key space name, and then either Google Cloud, Amazon AWS, or Microsoft Azure, and you can kind of pick, anyone. But the thing is, so far though, if you kind of only one available region is US East for Google Cloud. AWS is also US East. As such, right? These are pretty new. So also this one is West Coast for Azure. So yeah, so feel free to create it. And right now too, I do need to get going, so I'm not going to be able to do this to create it for you. But feel free over here, as you can see, right? This one here, how you can sign up is over here, astra.datastacks.com. Again, please sign up for it and start, playing around with it. And over here too, as you can see, right? There are also Q&A search with LangChain. LangChain is basically a framework to help you to leverage like large language models, LLM, to kind of do more, kind of like the return results. You can use LLM, in order to kind of further process it, right? So, or like Cas.io is basically Cassandra. As you know, Astra DB is Cassandra underneath the hood, and there's also a Cas.io database that helps you to basically helps you work with AI in a more kind of seamless, in a more seamless way. Let's put it that way. So, okay, so yeah, please give that a try. And then also too, with me doing streaming, I'm kind of like starting to study to retrieval augmented generation RAG for AI chatbots. So here's the thing, right? As we know, we train the model, and then let's say, right, you're training with a finite set of data. You train your model, and the model is there. What if there's new data coming in? So that model that you have, the trained model, doesn't already have the data, the latest data. So basically, too, this RAG kind of mechanism allows you to read in like newest data and then allows you to process it in close to real time. Not quite exactly as you know, right? So this is in an area that I'm myself am looking into. If I can also like set up some examples how you can essentially write your own rag, right? And leveraging on streaming platform. For example, Astra, we also have Astra streaming that's making use of Pulsar. So essentially, too, what I'm thinking is that I can actually stream in this new data, right? Stream in the data and augmenting my model, right? So adding in this new data to train your model on the fly, so to speak. So that's an area I'll be looking into. So I'm hoping to maybe get to a point in which I can kind of develop a like a snippet of code that I can leverage, taking in real time, newest, freshest data to train my model. So that's the next thing. And then, okay, so over here is just overview of AstraDB. So, okay, so I hope, you will be, kind of giving this a try, right? And so, yeah, so if you have any questions, let me know. Is there any question actually? And is anybody even there? So let me see. I think I see a few folks in here too. So thank you for joining me today. I hope if you find it interesting, or maybe it's too abstract right now. Don't worry about it. I hope you come and continue following me. I have more things for you, but it's just that I won't be traveling as much. I will still have some travel, but just less because there's just more work to do now, and also I'll be trying to do more like examples. A bit more streaming for you guys. So yeah, if you have anything you'd like to see, let me know too. All right then. All right, take care. Thank you everybody for having joined me today, and I hope you have a great weekend. Okay, bye.